This video is on solving quadratic equations with complex roots. Recall that if the value of the discriminant of a quadratic equation is negative, then the equation has no real solution. But it does have an imaginary solution. So let's take a look at a couple examples of quadratic equations that don't have real solutions but will have imaginary solutions. Our first one is x squared plus 4x plus 5 equals 0. Since that's not factorable, I'm going to use the quadratic formula. So x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a, which is 1, times c, all over 2a. Or x is equal to negative 4 plus or minus the square root of 16 minus 20, which is negative 4, so there's my negative discriminant, all over 2, and negative 4 plus or minus the square root of negative 4 is equal to the square root of negative 1 times the square root of 4, which is going to be I times 2, or 2I over 2. And that can be simplified by dividing negative 4 by 2 and 2I by 2. So negative 2 plus or minus I. And recall that that is actually two solutions to that equation, negative 2 plus I and negative 2 minus I. Actually, I don't like the way that looks. I'm going to write it as x equals negative 2 plus or minus I, because we did solve it after all. Okay, let's take a look at another example here. Here we have 3x squared minus 2x plus 2 is equal to 0. So again, using the quadratic formula, x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So x is equal to 2 plus or minus the square root of 4 minus 24, all over 6. Or x is equal to 2 plus or minus the square root of negative 20 over 6. And there's our negative discriminant. So x is equal to 2 plus or minus, and so the square root of negative 20 is going to be the square root of negative 1 times the square root of 20. 20 is 4 and 5, so this is going to turn into a 2 and then I square root of 5. 2I square root of 5 all over 6. And then I can divide 6 over 2, or 2 over 6 and 2 over 6 to give me x is equal to 1 plus or minus I square root of 5 over 3. My two imaginary solutions to that quadratic equation. So in this video, we took a look at how to solve quadratic equations that have complex roots. When we know that there's not going to be a real solution to the quadratic equation because the value of the discriminant is negative, we can use what we know about imaginary numbers to write the solutions as complex numbers.